Imagine the first time, not the first time anyone ever saw fire. Lightning has been setting things ablaze for hundreds of millions of years, and animals have been fleeing it for just as long. But the first time a hominin looked at fire and had a thought that no animal before them had ever had. Not run, not hide, not the deep, ancient, wired-in command to get away from the burning thing. Something closer to, wait, we do not know when that moment happened. We do not know who it was, what species they were, or what exactly was going through their head when they stayed instead of fled. What we do know is that at some point in the deep prehistory of our lineage, possibly as far back as 1.5 to 2 million years ago, some ancestor of ours began a relationship with fire that would end up being the most consequential relationship in the history of life on this planet. Not a metaphor. Literally the most consequential, more than photosynthesis unlocking solar energy for complex life, more than the Cambrian explosion of animal body plans. Fire, in the hands of a thinking primate, changed everything. It changed what we ate, what we looked like, how our brains developed, where we could live when we were awake, how we related to each other, and ultimately what kind of civilization we were capable of building. The entire human story after fire is different from anything that came before it in ways that most people have not fully reckoned with. Let us start with the most immediate and most dramatic consequence: cooking. Before cooking, early hominins ate raw food. This seems obvious, but its implications are not. Raw food, tubers, roots, meat, fruits, seeds, is genuinely difficult to process. Raw meat requires enormous chewing effort and is harder to digest than cooked meat. Raw plant starches are largely indigestible without cooking because heat breaks down the cell walls and converts resistant starches into forms that the human gut can actually absorb. Raw food also carries a significant pathogen load. The parasites, bacteria, and viruses that live in uncooked meat and unwashed plant material cause illness and death at rates that cooked food dramatically reduces. From a biological standpoint, cooking is not just food preparation. It is an external digestive process that the body no longer has to perform entirely on its own. Richard Wrangham, a Harvard primatologist, has developed what he calls the cooking hypothesis. The argument that cooking was not just a useful addition to the hominin toolkit, but the primary driver of the anatomical changes that distinguish Homo erectus and later species from earlier hominins. The argument is this: cooking increases the caloric yield of food dramatically, allowing the same amount of food to deliver significantly more usable energy. This meant that early humans could spend less time eating and less energy on digestion. And when the body no longer needs to devote enormous resources to a massive digestive system, those resources become available for other things. Specifically, the brain. The human brain is metabolically expensive in a way that is genuinely extreme. It consumes roughly 20% of the body's total energy at rest, a wildly disproportionate share for an organ that represents only about 2% of body mass. Sustaining a brain this large requires either a very high-calorie diet or a reduced investment in other energetically expensive body systems. The human gut is, compared to other great apes, significantly smaller. Our teeth are smaller. Our jaw muscles are smaller. We have a reduced digestive tract overall. These are the anatomical signatures of a species that outsourced part of its digestion to an external process, cooking, and redirected the freed energy toward brain development. This is not a small claim. It is a claim that fire, literally and directly, made us smarter. That the cognitive capacity you are using right now to follow this argument exists partly because some ancestor of yours discovered that meat goes further and tastes better when you put it near flames for a while. The timing of Homo erectus's emergence and the earliest evidence of controlled fire use aligns suggestively with this hypothesis. Homo erectus had a significantly larger brain than earlier hominins, a significantly smaller gut and jaw, and a body plan much closer to modern humans than to its predecessors. Whether this anatomy was the cause of fire use, or the result of it, is a chicken and egg question that may not have a clean answer. The two things probably fed each other in a cycle that accelerated over time, each improvement enabling the next in a feedback loop that eventually produced a creature with a brain capable of things no earlier organism had attempted. What is not in dispute is the downstream effect. A species with a large brain, small gut, and an external cooking technology that effectively pre-digested its food was a species capable of doing things that no previous organism had done. And the first of those things was simply surviving more winters. Heat. This is the second great consequence of fire, and in some ways the more immediately dramatic one. The human body is not well suited to cold. We are a tropical primate We lose heat through our exposed skin surface at rates that are genuinely dangerous below certain temperatures. Without clothing and without fire, anatomically modern humans cannot survive in environments that drop significantly below freezing. And even with clothing, fire is the difference between a camp that kills you in your sleep and one that does not. Fire extended the habitable range of every hominin species that learned to use it. It did not just make cold environments survivable, it made them livable. The difference matters. Surviving a cold environment means enduring it, staying alive through it at significant physiological cost. Living in a cold environment means using it productively, hunting its animals, exploiting its resources, building a permanent presence in it. Fire was what allowed the second, not just the first. The evidence for early fire use tracks very closely with the expansion of hominin populations into higher latitudes and colder climates. Homo erectus expanded out of Africa into the colder environments of Asia and eventually Europe, ranges that would have been effectively uninhabitable for a tropical primate without fire. Later, Homo sapiens pushed even further north into the Arctic environments of Siberia, and eventually across the Bering Land Bridge into the Americas, in conditions that made fire not a luxury, but an absolute requirement for survival measured in hours rather than seasons. In this sense, fire did not just change what early humans could eat. It changed where early humans could exist on the planet. It was functionally a form of biological range expansion achieved not through genetic adaptation, but through technology, something that had never happened before in the history of life, and has not happened since. Not to any other species, not to any other lineage. Only us, a tropical ape that colonized the Arctic because it figured out how to carry warmth with it. The third consequence of fire is social, and it is arguably the most interesting because it is the least obvious. Fire reorganized time. Before fire, the end of daylight was the end of productive activity. Predators owned the night. Vision was useless. The options after dark were sleep, stay very still, or die. The behavioral rhythm of every animal without fire was dictated entirely by the availability of light. Active during the day, inactive at night, no exceptions, and no alternatives. Fire created an exception. For the first time in the history of complex animal life, a species had its own portable light source. A fire at the entrance to a shelter, or in the center of a camp, extended the productive hours of the day by several hours every evening. And what happened in those extended hours was not simply more of what happened during the day, it was something qualitatively different. The anthropologist Polly Waisner has documented, through extensive observation of contemporary hunter-gatherer groups, a striking difference between daytime and evening activity around the fire. During the day, activity was practical and immediate: food acquisition, tool making, processing materials, managing children. In the evening, around the fire, the register shifted completely. Stories, songs, discussion of people and events far beyond immediate necessity. Jokes, the working out of complex social relationships through conversation rather than direct action. Wiesner argues that firelight evenings were the crucible of human social complexity, the context in which the expanded social world of Homo sapiens was developed and maintained generation after generation. The ability to have sustained, relaxed, non-practical conversations by firelight for hours every evening created conditions that no other animal ever experienced. Extended periods of social interaction freed from the immediate demands of survival in a psychologically safe space defined by warmth and light and the implied presence of allies. This is where the deep infrastructure of human sociality, the storytelling, the cultural transmission, the theory of mind, the ability to manage relationships with large numbers of people across extended time, was built and practiced and refined and passed on. Consider what firelight evenings did for language specifically. Language requires practice. The more complex a language, the more practice it requires to develop and maintain its full range. A species that has several additional hours of social interaction every evening, hours in which the primary activity is conversation, develops language in a fundamentally different way than one that does not. The firelight evening may have been the selection pressure that drove human language from functional communication into the recursive, symbolically rich, narratively complex thing it is. The thing that separates human language not just quantitatively, but qualitatively from every other form of animal communication on this planet. In this view, fire did not just cook the meat that fed the brain. It also created the social conditions in which that brain could develop its most distinctive and consequential capacity. Fire made us smarter through cooking. It then gave us the opportunity to use that intelligence in the specific ways that made us human through conversation. The fourth consequence of fire is defense, and it is the one that most directly changed the competitive landscape for early humans. Early hominins were prey animals for much of their evolutionary history, not apex predators. Things that larger, faster, and better-armed animals wanted to eat: cave lions, giant hyenas, leopards. The full terrifying roster of Pleistocene megafauna predators had early humans on their menu. The evidence is in the fossil record, hominin bones with predator tooth marks. Not the other way around. Fire ended that. Not immediately, not completely, but decisively and permanently over time. Most large predators have a hardwired fear of fire that appears to be genuine and deep rather than learned and situational. They do not approach active fires. They do not investigate them out of curiosity. They retreat from them. This instinctive response makes evolutionary sense. In nature, uncontrolled fire is catastrophic for animals that cannot control it, and individuals that fled from fire survived while those that investigated it burned. The fear was selected for over millions of years before any primate began managing flames deliberately. For early humans, this meant that a fire at the entrance to a sleeping site created a perimeter that most predators would not cross. The night, which had been the predator's domain, the time of maximum danger for a species with limited nocturnal vision, became manageable. The sleeping group, which was the most vulnerable possible configuration of a social primate, could sleep with some reasonable expectation of waking up. This was not a small thing. The reduction in predation pressure on sleeping groups would have had significant effects on population growth and on the survival of the most cognitively capable individuals who could now live long enough to pass on their knowledge. Fire also changed the dynamic during waking hours. A group of early humans carrying torches or burning brands was a qualitatively different proposition for a predator than a group without fire. The active deployment of fire as a defensive tool, driving predators from kill sites, clearing vegetation to improve sightlines, using smoke to disorient or repel, extended the options available to early human groups in their ongoing negotiation with the other large animals sharing their landscape. Over thousands of generations, this negotiation shifted steadily in one direction. The fifth consequence of fire is specialization. The one that connects prehistoric life directly to everything that came after it. A group that does not need to spend every waking moment acquiring and processing enough raw food to survive has time for other things. A group that can survive a cold night in a defended, fire-lit shelter rather than exhausting itself. In fear has cognitive resources available for planning and problem solving. A group with extended evening hours of social interaction develops communication, knowledge transmission, and cultural complexity at rates that groups without those evening hours cannot match. All of this adds up over hundreds of thousands of years to a species with increasing cognitive and cultural complexity, increasing specialization of individuals within groups, and increasing capacity to modify its environment, rather than simply respond to it. Fire was not just a useful tool added to an existing toolkit, it was the first step in a chain of consequences that led to every other human technology, and every subsequent step built on the foundation fire established. Agriculture is a cooking technology applied at landscape scale. The early humans who figured out that heat transforms food eventually became the people who figured out that deliberate cultivation of specific plants, managed and harvested and processed with fire, could produce food with a reliability and density that foraging could not. The transition to agriculture is in some sense a continuation of the logic that began with cooking. The logic of transforming raw nature into something more useful through deliberate human intervention. The campfire and the cooking pot are not separate from the plowed field. They are the same idea, grown larger. Metallurgy is fire applied to rock. The discovery that certain rocks, when heated to sufficient temperatures, produce liquid metal that can be cast into shapes was a discovery about fire as much as about materials. Bronze, iron, steel, the entire material foundation of human civilization from the Bronze Age onward, required fire of an intensity and controllability that developed over a very long time from the first campfires of early hominins. The smelting furnace is, in a continuous and unbroken lineage of human knowledge, a descendant of the first controlled hearth. Pottery is fire applied to clay. Ceramics enabled storage, transport, and cooking in ways that transformed the logistics of food and resource management for early agricultural societies. The fired clay vessel is such an important technology that archaeologists use it as a primary marker of cultural development and contact. The spread of pottery types across prehistoric landscapes maps the movement of people and ideas with a clarity that almost no other artifact type can match. Light itself, as a managed resource, connects the first firelight evenings to every subsequent illumination technology. Oil lamps, candles, gas lighting, electric light, every late night conversation, every book read after dark, every piece of work completed under artificial light is a continuation of what began at a Pleistocene campfire with a group of early humans doing something no animal had ever done before. There is also the psychological dimension of fire that rarely gets discussed but deserves attention. Fire is not just physically warming. It is psychologically regulating in ways that researchers are only beginning to quantify seriously. Studies of people watching and sitting near fires show measurable reductions in blood pressure and anxiety, responses that suggest our nervous systems have been calibrated to the presence of fire as a signal of safety, warmth, and social belonging over a very long time. The crackling of a fire, the flickering of light, the warmth radiating outward, these are stimuli that the human nervous system apparently reads as home. Because for most of human evolutionary history, that is exactly what they were, not a decoration or an amenity. The physical center of everything that safety and belonging meant. This is why campfires remain so universally appealing to modern humans who have no practical need for them. The gas fire in a suburban living room, the bonfire at a beach party, the fire pit in a backyard. None of these are necessary for warmth, for cooking, for light, for any of the original functions that fire served. And yet people build them and gather around them and find something in them that electric heaters and LED lights cannot provide. The nervous system remembers at some level below conscious thought what fire meant, what it still means, written into us over 1 million years of evenings spent around a flame. There is one more consequence of fire worth ending on, because it is the most intimate and the most strange. Fire changed what we look like, not immediately, not in a single generation, but over hundreds of thousands of years of eating cooked food. The human face changed in response to a diet that no longer required the processing power of a great ape's jaw. The large, thick, ridged brows of earlier hominins reduced. The forward-projecting lower face that great apes use as a platform for their massive jaw muscles receded. The teeth became smaller. The face became flatter and, in some sense, more expressive. Because a face that is no longer primarily a chewing machine has more surface area available for the communication of emotional states through fine muscle movement. The human face, the flat, readable, extraordinarily expressive face that makes human social interaction as rich as it is partly a product of cooking. We look the way we look, partly because our ancestors learned to apply heat to food before eating it, which over hundreds of thousands of generations reduced the mechanical demands on our jaws and freed our faces to become something more than dental equipment. Every time someone reads an emotion from a human face, the micro-expressions, the subtle movements of eyebrows and mouth corners that communicate what words do not and sometimes what words try to conceal. They are reading a face that became capable of that communication partly because of fire. It changed the food, it changed the body, it changed the brain, it changed where we could go and when we could be active, it changed how we organized our social lives and how we developed the cognitive capacities that are most distinctively human. And it changed what eventually got built on top of all of that. Every city, every technology, every piece of writing and music and science that human civilization has produced. The first hominin who stopped and looked at a fire and thought something other than run. We do not know their name. We do not know their species. We do not know what they felt in that moment, whether it was curiosity or hunger or something that had no name yet. But whatever it was the right thought. And everything that followed from it is the proof.